pretty much straightforward. This most students typically tend to clear. I'm not going to spend much time on it. So in moving and handling, I'm going to introduce an acronym. Okay? And to start off with, what do we typically tend to carry on site? Does anybody know?
Can you repeat the question, please?
What do we typically tend to carry on site? As in what we usually lift? Materials. What else do we lift?
Tools.
Materials and tools. Okay? And depending on the nature of the site, you will have different types of moving and handling aids. Right? Can we just mention some of them?
Lift.
Scissor lift, for example, or a lift. Frames.
Trolley.
Trolleys, yeah, very common. Forklifts. What else?
Dump trucks.
Dumper trucks, correct, yes.
Wheelbarrows.
Wheelbarrows, yeah, very common. Sack barrows. Pallet trucks. What else? Trolleys. Wheelbarrows. Have you heard of curb lifters? Like lifters of pavements? No? Okay. Suction pads? Yeah, especially heavy glass. Okay. When undertaking a manual handling activity, the regulation requires or stipulates that you walk through a series of thought processes. One of them is you assess the task. When I'm using the word assess, I'm not asking you to do a risk assessment. Please don't. Okay? This assessment is to think about the task that you're going to do. Okay? And then here you think about the individual capacity. An individual capacity means you as an individual. What are you able to be comfortable with to carry on your own? Okay? Everybody has a different individual capacity. So after assessing the task that you need to do, and you've got to think about what can I do on my own? If you need any manual handling aid, that's when you start putting that into consideration. And then here, you're going to assess the load. Okay? And assessing the load, you look at the size of the load. Okay? Is it too big? And therefore, it causes safety risks. And can it be broken down? Breaking down the size, the load, into smaller components. Okay? So you need to look at the size, weight. Now, I've got news for you. There is no minimum or maximum weight. That doesn't exist in the regulation. You make your own assessment as to what weight is comfortable for you. Okay? And also the size, if it is too big, you break it down. Okay? And also with the load, you consider what sort of manual handling aid is going to be appropriate. If you are in the process of building the pavement, or working on the pavement, you have to get cards or pavers. How are you going to carry them? As opposed to someone who is working with bricks and they are literally laying bricks one on top of the other. How are you going to carry them? Or if it is a bag or bags of cement, what weight is there? How comfortable are you to carry it? Distance, okay? You're going to probably look at distance, look at that environment, but that's what size and weight stands for when it comes to the looking at the load. Then E is the environment, okay? Every environment is different depending on what you need to carry, be it tools or be it materials. If you're doing a private job, for example, and you're doing it with your mate and you're going into somebody's property, you know, first and foremost, the distance between where you parked your vehicle and where the property is might be a huge distance. You've got to think about how you're going to carry materials and tools there. You're also going to think about the lighting, especially on site, between the storage warehouse and your place of work, okay, in terms of what we're going to be doing there. You're going to look at things like the clarity of route, okay? Is the route clear? If I'm using a wheelbarrow, or am I going to be going over different articles of obstruction? Okay, am I likely to trip? Are there cables? So, environment, you look at things like distance, clarity of route. Okay, you're going to look at lighting. Okay, these are some of the things you're going to have to think about. But you're also going to think about like organizational factors. And here, it doesn't mean that you are going to Google the company and find out. Working for particular sites, you see what their appetite is like towards moving and handling. Some sites have policies, some have posters which inform how they approach moving and handling. You know, I've been in classes where students have told me, my site, mate, we do everything. We carry stuff on our backs, on our shoulders. These guys give us nothing. So you can tell that their risk appetite when it comes to moving and handling is a non-issue to them. And some sites, they're so pedantic. Even if it is a pen, they bring you trolleys, stuff like that. So these organizational factors, you consider them and seeing how you can get the support of the organization when it comes to moving and handling. So things like policies, things like procedures, okay? These are things to put into consideration when doing moving and handling. Now, most people will tell you, being in construction for a long time, mate, just get on with it. Get your tools, get your materials, get your job done. All the stuff you're talking about is theoretical. Doesn't necessarily happen that way, okay? Yes, it is, but this awareness is helpful, okay? Where everybody just carries on like there is nothing to look out for, this awareness will help you make the right decisions, subtle decisions, because with moving and handling, there are quite a number of risks or potential illnesses, yeah? Things like musculoskeletal disorders, for example. This thing is complaint, but I've abandoned it, yeah? Things like back injuries, okay? Hernias, okay? Musculoskeletal. Disorders, okay? All these are potential injuries. Sprains, okay? These typically do happen, especially in construction. They happen a lot, okay? So that's why assessing before doing manual handling, however minute, is not a waste of time. It never has been, okay? The other thing that we're going to look at when it comes to manual handling is what we call the dynamic or kinetic manual handling technique. Let's look at it now. You'll get a question there, certainly. Okay, I'm going to go through some questions to do with moving and handling as well. Let's look at what we call kinetic manual handling technique. Okay. Kinetic moving and handling technique. Okay. One is back straight. Okay. Feet apart. 1 foot slightly ahead. Bent knees. Okay. Back straight, feet apart, 1 foot slightly ahead. Bend knees and push the weight up with your legs. In every exam, this will come. It may just be done differently, but it will definitely come in every exam with manual handling. Okay? So there are manual handling things like back support. The back support will not prevent someone from getting a back injury if the manual handling technique is wrong. You know, it's just like saying I've got an airbag in the car. It will not stop the accident if the driving is reckless. Okay? So some of these are reduce the impact of the consequence, but they never reduce the likelihood of injury. Okay? So push the weight up with your legs. These are some of the manual handling technique. Let's answer a few questions when it comes to manual handling. Because questions right. A large bag of cement has been placed on a high shelf. Okay? What is the most serious risk involved? The bag may A. become wet, B. damage the shelf, C. fall and hit someone, and D. spill cement on the floor.
B. B.
Can I repeat the question?
B.
Interesting. A large bag of cement has been placed on a high shelf. What is the most serious risk involved? The bag may A. become wet, B. damage the shelf, C. fall and hit someone, and D. spill cement on the floor. C. fall and hit someone. Okay? When carrying tools or heavy materials upstairs, the workers are most at risk from A. an electric shock, B. manual handling injuries, C. an vibration injury, and D. being hit by moving vehicles. B. manual handling injuries. Okay? A worker is carrying a sheet of plasterboard in their arms. This is most likely to lead to, these are how the questions will appear. This is most likely to lead to A. stress and lost work time, B. a back injury and time off work, C. vibration white finger and time off work, and D. skin cancer and insurance claims by the worker. What's the answer?
B, no?
Sorry?
B?
B for Bravo. Yeah. A back injury and time off work. If a load needs to be lifted from the floor, okay, you should A. lift it as quickly as possible, B. hold the load away from the body, C. push yourself upright with the legs, and D. keep the legs straight and the back bent. Answer is C. You push yourself upright with your legs. Okay? Final question. Steel toe caps inside safety boots should offer protection against A. falling from a low height and landing on the feet, B. nails and sharp items left on the floor, or in the ground. C. Slipping on oil or chemical spills and other wet surfaces. And D. Heavy objects dropped by a worker and carried.
B.
D. Heavy object. D.
Okay. The steel toe caps inside safety boots should offer protection against A. Falling from a low height and landing on the feet. B. Nails and sharp items left on the floor or in the ground. C. Slipping on oil or chemical spills and other wet surfaces. And D. Heavy objects dropped by a worker when carrying. The answer is D for Delta. Okay? The steel toe caps are right at the top of your boots inside. So when items fall, instead of crushing your toes, the steel toe caps will offer protection. Okay? That's what they are used for. Okay? If the safe method of handling described in the method statement cannot be followed, a worker should. Okay? I'll read that question again. If the safe method of handling described in a method statement cannot be followed, a worker should A. Stop that task and start another one. B. Report the problem to their supervisor. C. Use a faster method to get the work done. And D. Borrow equipment from another contractor.
D.
The answer is B. Report the problem to their supervisor. Okay?
Well, all the questions are going to be that easy though.
Sorry?
Are they all going to be that easy?
They are all this easy, but you do get some.
It's just how they word them.
Yeah.
And they just like literally just change the wording.
Yeah, but this is how they come. In the exam, it is important that you read carefully because they're looking to catch you out here and there. So there's some subtle changes. If you read it again, you're like, I see what you wanted to do. If you rush through it, chances are very high you might not get the right result. Okay? Right. Let's look at working at heights. Okay? That's another 5 marks, by the way. 15 out of 25. Done. On level 1, at the very least. And a significant amount of CSCS. Okay? Working at height regulations, 2005.
Can I have another piece of paper, please?
Yes, you can. No need one. Anybody else? You're okay, please go. We know that falls from height are the main cause of deaths in the UK construction industry. Okay, that question is very, very common. Falls from height, main cause of death or injury in the UK construction industry, and it has been for the last 15 years at the very least. Falls from height every time. Okay, do we know what working at height is as a definition, or what you understand by it?
It's working at like anything that's just above. It's anything that's lifted. You said it the other day.
Is it like working at anything which can cause injuries before?
Yeah, that's the one.
Any height.
Yeah, it's any height.
It's any height where you could fall a distance, and if there is no precaution in place, that's liable to cause injury. Okay? So that's what working at height is. Any place, if there were no precautions in place, a person could fall a distance, liable to cause personal injury. Okay? That's what working at height is. Okay? And Can we just name, just like we named hazards, some examples of working at height? Scaffolding, big time.
Roofs, ladders.
Roofs, ladders.
Harness.
Sorry?
Tower.
Tower.
Harness.
Harness, yeah, that's one of the equipment used to work at height.
I'm saving.
Sorry?
I'm saving.
What's that?
I'm saving.
Upsailing.
Road access technician.
Okay. I didn't catch that. Upsailing, you see.
I'm saving.
Upsailing.
Abseiling. Like when you go down like a building, you've got like wires connected to you, like to clean windows and stuff like that.
All right. Okay. Yeah, that's very, very common. Yeah, and that kind of work, you tend to have safety nets at the bottom as for arrest mechanism. Cherry pickers. Yeah. Mobile work elevated platform.
Scissor lifts.
Yeah, it's a scissor lift, actually that's what it is. Mobile work elevated platform and scissor lift are one and the same. Anything else? Examples of working at height?
Balcony.
Yeah, if you're working a balcony. Yeah.
Crane drawers.
Cranes. How about podiums? Yeah, podiums are also examples of working at height. Sorry? Fragile roof, that's very common, yes. So we've seen all the examples. Typically, majority of the work in construction involves working at height at any given point in time, is that right? That's why it is very, so much of a big deal, because in UK has a finite land resource. It is not, or everybody has a finite land resource, but the UK's land is, a lot of it is reusage at the moment. It's a small island, and you find that the buildings are more likely going to go upwards. You find that there are some parts of the world where there is still a lot of space for construction, and that means that not majority of the buildings will be going upwards. Some will just be on a particular level that wouldn't require that much of a risk working at height. But for the developed world, working at height is the way to go, okay? To make better use of space, okay? And that's an example of a mobile tower, okay? How do you access a mobile tower? How do you get inside?
Inside with a
From the inside, okay? And under what circumstances are they used, mobile towers?
On even ground.
So it should be even ground. The ground should be risk assessed. And the weather conditions must be conducive. Cannot be too windy because it has a high center of gravity, as you can see. And you also notice that it's got a maximum capacity. You can't put too much on there, right? Is it advisable for the use of mobile towers outside, do you think, for a long time?
No, short period of time.
Short period of time, preferably indoors. Yeah. For example, if St. Paul's Cathedral needed repairs, I foresee a scenario where mobile towers are used inside, as opposed to outside, where the external variables would cause massive risk. Okay, because the tower can collapse. Okay. In working at height regulations 2005, which by the way you need to remember, working at height regulations 2005, we've got what we call the hierarchy of controls. Okay? Hierarchy of controls. Hierarchy of controls is a progressive thought process that is designed to inform how risk is managed during the process of making a decision working at height. What does that mean? The first thing you have to think about is whether working at height can be avoided. So number one is to avoid working at height where possible. Okay? Working at height where possible. And you'll get a question in your exam, both level 1 and CSCS. That question will be, what is the best way of managing the risks associated with working at height? The answer will always be avoid working at height where possible. That's what the answer will be. Okay? So avoid working at height where possible is the first hierarchy of controls. Okay? The second one is prevent falls from height and falling objects. Okay? Prevent falls from height and falling objects. This is where we look at what we call fall restraint. Okay? Prevention. This is the most commonly applied. Okay? You cannot stop or avoid working at height, but there are all sorts of ways of preventing falls from height. Looking at the example of our scaffold, scaffolding these are called tall boards, and obviously the use of the tall board is to prevent tools and materials from falling down. Okay, against preventing falls from height. This prevents the operative from falling through. It's called the guardrail, and the scaffolding is inspected periodically. And what is the evidence of inspection of scaffolding? Does anybody know? Sorry? The scuff tag, yeah. It's got to be there, it's got to be in depth, okay? All that I'm saying, by the way, will come in exam, okay? That's the evidence of the inspection. This scaffolding has got to be erected by a certified person. They've got to be companies that are listed and the HSE is aware of them, okay? Does that happen all the time? No. Some people cut corners. I keep on giving the same example of a student who shocked me when he said to me that he fell through scaffolding that was badly done and it injured the side of his ribs. And he was talking casually, and at first I was like, he's one of those students just trying to disorganize the class. And he said he fell through, he was off work for a number of weeks. But what happened is that he had to claim compensation. He's been out of work. He's had an accident at work. What do you think should have happened after that accident? What should the manager have done?
Should call in the
Sorry?
Inspect the car.
No, after let's go through the accident. Inform the health and safety executive under the REDO regulation. So this guy now tells the insurers and the people around him, I need compensation, I've not worked for a long time. So the insurance companies, what do you think they do? They find out if process was followed. They will check with the health and safety executive. Let us know, did this actually happen, or is this guy just trying to take money off us? And the health and safety executive were like, well, we are not aware of this incident. So then they had to go back to the company. So you can imagine the manager must have been a spot on further, because typically this guy could have died. So lucky he survived. And you have the cheek to carry on like nothing happened as a site manager. I found that story so interesting because it does highlight where the gaps are and what could potentially go wrong. So the scaffolding, and he was very honest that, well, we don't inspect our scaffolding. We go up with our tools and everything. It was a very risky site. I wish I took down the name of that company because it was really not very good. Anyway, the scaffolding tag, the scuff tag is evidence of inspection of scaffolding. Okay? The third hierarchy of control is what we call the reduce. So this acronym is APR. Okay? Reduce the consequences of a fall. Okay? Should a fall happen? reduce the consequences of a fall should a fall happen. Okay, and that's where, in some instances, you see the safety net being used, or inflated airbags, or the lanyard. Okay. This is not very commonly applied because you need space, and not many instances you have space. That's why I say number 2 is the commonest. I mean, just imagine if you're putting up a residential complex, blocks of flats, and you're going to have a Tesco's in there, you're going to have all sorts of facilities. It's not very easy to protect all the employees working at height with a safety net. It's actually not practical. There are instances where the consequences of overfall are reduced by these mechanisms, safety net and inflated airbags and stuff like that. And this is what we have what we call fall arrest. In your CSCS, you get the difference between fall arrest and fall restraint. Okay, one prevents, okay, but one reduces the consequences. In other words, you fall, but rather than breaking your ribs or skull or your backbone, you'll be trapped by a mechanism that makes sure you don't get injured. Okay, that's what happens. Okay, let's look at yes.
The fall arrest, is it the one that prevents? Or?
As you can see, fall restraint is preventing. I'll show you a diagram that will make you understand. That prevents. Arrest traps you. Okay? You have fallen. If that thing wasn't there, you would have died. And it has arrested the situation. That's a fall arrest. Fall restraint, you don't get to fall. You don't get to a place where you fall. Just like the diagram there. Fall restraint systems prevent you from falling. They use a body holding device connected to a reliable anchor, preventing you from reaching zones where the risk of fall exists. Okay? I was probably moving too fast. That's what a fall restraint does. And the scaffolding example is what we used to demonstrate falls restraint when we had the tall boards and the guardrails that prevent us from falling through. Okay? And let's quickly look at ladders. Are you still writing? Okay. Let's quickly look at ladders. There are usually 2 questions that come in this section to do with ladders. The first one is the ladder is positioned at a correct angle of 75 degrees, and the second one is you inspect the ladder before use. Who inspects the ladder before use? You do, the user. Okay? And the rest of the things about ladders is a lot of common sense, quite frankly. I know it is not common, but it's common sense. I.e., weather conditions, using it on even ground. Not 2 people can be on the ladder at the same time, overreaching, too much load. The right PPE, the right boots on the ladder, 3-point contact. These are some of the things that typically tend to come with the exam, signing a ladder, but they're quite straightforward. Okay? We've talked about mobile tower scaffolds, and these are some of the hazards that could go wrong in mobile tower scaffolds. Falling objects, vehicles colliding with the tower. That's why we say it is best they're used inside, and then the overturning of the tower that is unstable. It's got a very high center of gravity. I, for one, want to use it, to be honest. But that's just me. Yeah, I'm sure on site, when it is secured properly, you don't even think about that. It is safe. Okay, and these are the don'ts. Mobile tower scaffold. The one that I really want us to look at is that will come in exam is called Mobile Work Elevated Platform, also known as a scissor lift. Okay? There is a question in your mock exam that will ask for what that abbreviation stands for. Okay? It's another way of working at heights. Scissor lifts or cherry pickers. They can only be used for a short period of time, short duration, where ladders can be unsafe, or where scaffolding is not cost effective. Okay? You can use the mobile elevated work platforms. Okay? Please remember that. That comes in the exam. I know that for sure. Okay? Let's look at safety signs. See if I've got one or two questions to do working at heights, even if they're the difficult ones. Because you did ask a legitimate question. Are they that easy? Let's see which one. Okay, there are two here. One of them reads, workers should be prevented from falling from flat roofs. Suitable control measures for this include A. Providing temporary edge protection on the roof. B. Telling the workers to keep away from the open edge. C. Keeping members of the public away from the area. And D. Limiting the amount of time spent on the roof to 1 hour.
C.
So you read it again, please?
I'll read the question again. Workers should be prevented from falling from flat roofs. Suitable control measures for this include A. Providing temporary edge protection to the roof. B. Telling workers to keep away from the open edge. C. Keeping members of the public away from the area. And D. Limiting the amount of time spent on the roof to 1 hour. The answer is A. Okay.
Read it again.
Providing temporary edge protection to the roof.
What's that?
Okay.
So you don't fall off of it.
For example, if this is the edge, we put protection.
Oh, edge. Oh,
Yeah.
because it's the way that you're pronouncing it, not really.
Temporary edge protection. Yeah.
The edge protection.
Yeah. So that is sorry.
Okay, sure.
So that is the right answer. 26. According to the work at height regulations, the best option for managing the risks involved in working at height is to A. Avoid such work where possible. B. Provide information and instruction. C. Limit fall distance using nets and marks. And D. Limit fall distance using fall arrest units. The answer is A. Okay? Avoid such work where possible. Okay, let us look at safety signs, which is very straightforward. And please remember what colors you want. Okay? Red is a prohibition sign. Green is a safe condition. Blue is mandatory sign. Yellow or orange, warning sign. Okay? Pretty please remember this, because this will come in your level 1 without a shadow of a doubt. But let's look through some of them. Okay? When used on site, what's the meaning of the sign about? Talk to me. The answer is
B.
it should be B for Bravo. Okay? And then the second question then is, what is the meaning of the sign below? The answer is B, assembly point. And which of the following symbols means flammable?
D.
The answer is D. Okay? Is that flame that has D in front of it? Yes. And what is the meaning? Yes. Thank you. Okay, what is the meaning of the sign below? That one there.
Exposure.
Which one?
The sign,
C.
the number 4 there. Yeah.
B.
The one at the bottom.
Oh, that one.
Yeah.
Oh, B.
B. It is explosive. Yeah. Number 5 up there. Which of the following symbols means dangerous to the
D.
environment? D. And which of the following symbols means corrosive?
C. C.
What does the sign above tell you?
Head protection.
Risk of head injury. Answer is B. Okay. And number 8. Which of the following symbols means harmful
C.
or irritant? The answer is C. Okay. Number 9. What color are fire exit signs?
Green and white.
Green and white. And the number below, that question should read, what does that sign tell you?
A.
Okay?
Oh, yeah,
It means B, not A. That sign means laser radiation. And number 11, when used on site, what does that sign mean?
C.
It's the risk of high voltage. The answer is C. And the question below, what does that sign in the picture mean?
B.
Forklifts in use. What is the main color on a sign that states that you must not do something?
Red and white.
Red and white. The answer is B, prohibition. That question below should read, what do blue and white safety signs tell you?
A.
The things you must do, mandatory. Number 15, which of the following signs means fire point? C. And what does the green and white sign mean?
D. A. D.
Safe condition, okay? Which of the following signs means oxidizing agent?
D.
A.
It's the yellow one, correct?
Yeah, I thought that was D, no?
Yeah, yeah, you're
That's
right.
flammable.
It's the yellow one. It's
Yeah,
supposed to
it's
be
like
A,
D.
yeah, yeah. And what's the question below? What does that sign mean?
Harmful.
The
B.
question below, what does that sign mean?
B.
It's a biological hazard, okay? And which of the following signs means hearing protection must be used? D. And what does that sign below tell us?
C.
No escape route.
No escape route. That's correct, okay? Now, before I proceed on to the next area, I want us to review working at height. There is something that working at height, there is something that is going to come in the exam, which is this regulation, 1998 regulation. That one there is called Provision and Use of Work Equipment Regulation, PURE. And that very abbreviation, that is going to come in the exam, working at height. It's going to be one of the 5 questions. For at least a few of you. And it says this regulation deals with the work equipment and machinery used in everyday workplaces, which aims to keep the people safe. That's all it is. But the abbreviation, 1998, it tends to come in the exam. Okay. Is there anybody here who is 16 years and below or thereabout? No. Because there is another provider called City and Guilds. It's the same outcome, level 1, but they do tend to set their questions differently. So if any of you is going to be doing the City and Guilds, we will have to go through what we call practice session before you actually sit your exam. I don't know who it is among you, but one of you will be doing the City and Guilds, I'm told. I just thought, City and Guilds, the provider, doesn't change anything.
Was that for 16 and under?
16 and under, or people who booked their exams very late. So if you booked this course this morning, for example, or late last evening, chances are you're going to be put on the City and Guild. Yeah? They're just a different provider, but it's the same content.
How would you know you didn't see it through?
You're going to find out from the admin downstairs. Yeah. Whoever it is, they'll tell you. Sometimes you get to know, but sometimes you don't tell you. Okay, let's look at working safely around that. Now, this is a big area. And for the last 3 months, I would say 2 months, I found that students failed it a lot. So I have found a video that introduces us to this topic, which I want us to share. And I found that the pass rate has gone up by virtue of the fact that I changed working safety around plant, working safety around plant.
Hello, Miss Billy. Bluetooth mode.
Vehicles. Okay, plant. As we can see, excavators and loaders, dumper trucks, drivers, plant operators, these are some of the hazards. How about traffic marshals? How are they hazards?
They may not be signaling properly.
Exactly. Banks person. Do you know what a banksman is?
Is it direct to vehicles?
Sorry?
Would you like direct crane?
They're signalers of plant, for example, cranes and stuff like that. They can be a hazard, especially if they are absent-minded or if they are negligent. So these are typical hazards. The other hazard could be also an uneven surface. Okay? Do you know why? Because if it's uneven, then a dumper truck, for example, could lose control, could tilt over time, right? So that becomes a hazard. Poor lighting is a hazard, yes.
What about soft ground?
Yeah, soft ground, correct. Very correct. Soft ground, poor lighting. Okay, these are big time hazards. Okay, what are the risks or likely consequences of hazards? What are they?
Reversing.
What happens after the reversing?
Yeah. Run over.
Yeah, being run over, being struck by a reversing vehicle, or run over by a reversing vehicle.
Getting struck by material.
Yeah, being struck by falling debris. Okay. Collisions. What else? Vehicle overturning. Yeah. Especially when you have this soft ground and uneven ground.
The operators accidentally turning a machine off.
Sorry?
Like the operators, when they're climbing out of the machine, they could turn it back on or something like that.
Yeah. Accidents during climbing out of the machines. There are others that I want to put down here. Being crushed between a structure and mobile plant as it slows around, overturning, loss of control. Yeah.
Speeding.
But what has speeding led to? It has got to be something that, because speeding is speeding until it leads to something.
Going over the speed limit on your side.
Yeah, that is pretty much right. I would say one of the controls here is speed control. Controls is 5 miles per hour speed limit. Okay, the other one we just looked at, which is safety signs. Safety signs will give direction to drivers across the board. Another control, high vis, yeah. High vis, lighting. You make sure that the site is well lit in that area.
Yes. Is the marshals mandatory? Like, do they need the marshals?
They need, I would say the
Give them your
competence
passport,
here. The risk here is
Your
they
passport.
need to be competent. So
You give them, eh?
traffic marshals
They
and
give you back?
advanced person.
When finished.
Okay.
Okay? Traffic marshals and banks person. This is proper training. Okay, that's one of the controls. The other controls, when it comes to when the vehicle overturns, to protect the driver, we have what we call anti-rollover bars. You're going to get this in the exam. And cages. Okay? This is very commonly set in the exam. The other control is 5 miles per hour speed limit, safety signs, high vis, lighting, traffic marshals, banks, person training, anti-rollover bars. How about barriers to separate from
pedestrian route.
yeah, barriers separating.
What about the blocks that stop it from driving into excavations?
Yeah. Separate pedestrians from vehicles. Then we have also restricted access areas. That's why the man said that there's so many hazards, but there are enough controls in place to make working in this environment safe. Okay? Now, there's so many questions that have been answered by just going through, again, our risk hazard control walkthrough. And this is the best way to reduce transport accidents on construction site is by organizing and controlling sites such that vehicles and pedestrians can move around safely and are kept apart as much as possible. And pretty much that is the name of the game there. So what we're going to look at here is machine safeguards, okay, on site. And again, I'm going to show you a 5.5-minute video of machine safeguards. Because what it is that I tried explaining this, and most people I found may not necessarily have encountered what these are. So let's look at machine safeguards here. is usually 1 or 2 questions that are set. That's another one. That's out here. It is very commonly set in the exam. Working safely around plant, the fixed guards or the fixed barrier guards are the best means of protecting you from injuries as a result of using machines and equipment on site. Let's look at it here. Terrain. Look at that. The importance of safeguards. Using fixed guards secured with screws, nuts and bolts to enclose the dangerous parts of the equipment where practical. They are the best ones to use, fixed guards, and if not, then use the interlocking guards. There tends to be a question on fixed guards or machine safeguards in your exam, especially the level 1 exam. So that is the area around working safely around the plant. Now I want us to look at fire and fire extinguisher. Question is, do you guys want a 5-minute break or you want me to crack on? A little break, stretch your legs, we're going to crack on, because I can crack on with fire and fire safety. Okay, let's do that then. Your answer told me that you're fine to carry on. You want more paper? You're making stuff comfortable. Right. What is a fire triangle? Does anybody know?
Oxygen, fuel.
And what else? What's the fire triangle?
It's not CO2. No.
Fuel, oxygen, that's correct. What is the third?
Is it heat?
Yeah, it is.
Fuel, oxygen, and heat. That's correct. The 3 elements that should be in place before a fire can start. Fuel, oxygen, and heat. Okay? That's a fire triangle. Under what scenarios would there be a risk for a fire to start on a construction site?
Unsafe, hot works.
Hot works. Okay? Hot works. These are the type of work activities that would potentially cause a fire to start on site.
What's the fire triangle again?
Heat, oxygen, and fuel.
Right there, fuel, oxygen, and heat. Hot works. What are examples of hot works?
That.
Soldering,
Soldering,
asphalt,
Welding.
yeah.
that's what it is, the ground.
Yeah, using an angle grinder. These are examples of hot works. What needs to be obtained before hot works are carried out? Does everybody know?
The work is that.
Hot work permit. Okay? Hot work permit. Okay? That needs to be obtained before hot works. And in order to carry out hot works, you need to have a fire extinguisher nearby. Okay?
I know where they're located.
Okay? You need to have an escape plan. And after the works are finished, one person stays behind at least an hour after. At least 1 hour afterwards. Okay? Why does that person stay behind at least an hour afterwards?
So they're nice safe.
So that they make sure that the fire does not start out after the works are completed. Okay? And then the hot work permit can then be signed off these are the conditions under which hot works are going to be issued. Hot work permit, okay? Now let's look at the extinguishers and their codes. What these extinguishers do will come in your level 1 in terms of what they do, what they look like, and what is in them will come there in your level 1. The red fire extinguisher is the water fire extinguisher, okay? The foam has got a cream strip, and the powder has got a blue strip, and the carbon dioxide one has got a black strip, and the wet chemical has got a yellow strip. Just before we talk about what they are used for, it's important for us to recall what is inside of them, okay? And I'm just going to talk about some of them and the questions that you're going to get in your exam concerning the fire extinguishers. For example, let's look at the water fire extinguisher. It is used to deal with dry combustibles. For example, wood, textiles, and plastics. Okay? That's what you use the water fire extinguishers for. Okay? And how does it take out the fire? Cools the burning material. That's how the water fire extinguisher works. Okay? But what you can't use it on,
Electrical fires.
okay? You can't use it on electricals, and you can't use it on what we call flammable liquids. You can't use it on those two. Okay? Why can't we use it on flammable liquids? Because it makes the fire
Reactive.
spread more. It aggravates the fire. It is a dense material, so water will displace the flammable liquid and will give it access to more oxygen. It's not a good idea. Okay? So let's look at foam. The foam fire extinguisher looks at, for example, flammable liquids. That's what's best used for. This is petrol, diesel, kerosene, etc. We use the foam fire extinguisher. Okay? And what you cannot use it for, cannot use it for electricals, and you can't use it for molten metal. Now, this doesn't make us experts, but these are the questions that will come in exam, really. You're not going to use a fire extinguisher probably the entirety of the time you're on site, okay? But for the sake of the exam, both level 1 and CSCS need this information, okay? Then we've got our CO2, the carbon dioxide, which is the black strip, okay? Upon use, the nozzle gets very cold, okay? And it is used for electrical fires. That's what carbon dioxide fire extinguisher is most appropriate for. Okay. You notice I've left out the powder fire extinguisher, which is blue. It is multi-purpose. Powder fire extinguisher, multi-purpose. Powder, which is blue. Strip. This is multi-purpose. It's used on everything. Okay? And then wet chemical is only suitable for kitchen fires, which is yellow strip. This is suitable for kitchen fires. That's what it is suitable for. Okay? By show of hands, who are those that are here only to do one exam, level 1? Just the level 1. Yeah? 1, 2, 3, 4. Okay? This is what I'm going to do. Because what I'm covering now, a lot of it is CSCS. And I'm going to carry on teaching, but what you're doing, going to do for me, is you're going to do this exercise. Okay? Which I will mark, and then, yes. Question, why is it important to uncoil a cable, electricity cable on site?
Why is it important to do that?
Why is it important to make sure it is uncoiled?
Check if it's damaged.
Yes, to check if it's damaged, that's very true. What else?
Also, don't get tangled up on something. I don't know.
To check if it's damaged. The second answer is also to prevent it from overheating.
Oh, yeah.
Yeah, deals with the overheating aspect of it. That's why it is important to uncoil it. Another question, why is it important that all cables are trunked? I wonder what happened to that gentleman there. Wow. Okay. Maybe hope he's alright. Because, yeah. So why is it important to get all the cables that are running around and they are trunked or they are put on the side? Trips and falls, slips, trips and falls are avoided. Okay? And when it comes to electricity cables that are running overhead cables, okay? Now listen to this carefully, and I'm giving away an answer in the exercise these guys are doing, but I have got to teach it to you. It's called flashover. Okay? Has anybody heard of that term before? Flashover. Flashover is when electricity skips gaps, overhead cables. Electric current from overhead cables skips gaps, and if there is a conductor in between, for example, if there is a human being in between, you could be electrocuted. You've not touched anything, but because electricity running through overhead cables has a capacity to jump, especially if those overhead cables are somewhere close to one another. Okay? So flashover is when electricity current from overhead cables can jump between conductors.
Okay. We use that word in the test.
Yes, flashover. It's going to come in example. Yes, come in please. Daniel, no. Yes, sir. You want to take here? I'll finish with these actually. Then I will. Flashover. Typically what happens is electricity jumps.
Jumps over what? What's the angle?
Okay, there's a cable here, a cable there. This is you here. And the ability for current to skip this gap, skipping between gaps. So if you happen to be here, this current could shock you. That's a flashover. Okay? That's what that term typically means. Right? Now let's look at the use of a transformer. Okay?
Was a RCD.
Transformer. This one here.
So that lowers the voltage.
Yes. Transformer does not split, but transformer actually reduces the voltage. Yeah. Reduces the voltage from, no, not from, you reduce to, you alright?
Yes, it's been that I misunderstood. I already done the level 1, so I had only to practice and to done the test.
Okay, okay.
Yes?
So you got it, so you might as well sit on the terminals and do the practice.
Yes, I mean, it's been very helpful,
Okay.
but it's been a bit misunderstanding.
Okay, no problem.
Thank you so much, Nico.
You're welcome. Reduces the voltage to 110 volts. 110 volts from 30 to 40 to 40 volts. Okay? That's what the transformer does, usually getting current. Okay? When you're doing this exercise that I've just given you, it's best not to refer to your notes. Just to see how much you can remember. Is that all right? Yeah. That's the whole point of it. Yeah. Okay. Okay.
Bye, guys.
So reduces the voltage to 110 from 240. Why do you think it does that? Why do you think we have a transformer on site?
Makes it safer.
Makes it safer.
Less
Okay?
likely to kill you as well.
Exactly, it's less likely to kill you. But you also find that there are scenarios where certain equipment cannot function properly with 200, 110. They need to operate on a 240. So we have what we call a residual current device, okay? Especially a portable one. A portable residual current device is placed between the power source and the equipment, and what is used for residual here is residual current device. Okay? Residual current device. Okay? This one is used to traps the power, trips the power in the event of an uneven surge.
So what if there's a fault in the tool, it turns it off?
Exactly, it cuts it off. Okay? So, and also make sure that you're not electrocuted in the event the uneven surge causes electrocution. That's what the RCD does. It's usually placed between the power source and the tool. And I think I can show you an RCD in operation here. Okay? It's not going to be the best of videos here, but not videos, sound, but it does. Okay, let's see this. Portable RCD in use. Confined spaces and underground services. So let's look at the tools that are used. You will find in your CSCS something we call a CAT scanner, okay? CAT scanner, okay? And the use of a CAT scanner, this stands for cable avoidance tool, okay? Cable avoidance tool. Cable avoidance tool is used to detect whether there are underground services on a particular piece of land. And they're usually used to map out where the underground services are, and hypothetically also what distance they're at. So the PPE usually that's used, okay, for the operative who are digging for these services is insulated rubber gloves, insulated rubber boots, okay? This PPE is very important. And also you're going to have tools such as insulated spades or shovels. So when the work commences, it commences by using equipment such as the normal diggers, okay, that would excavate up to a particular depth that is safe enough to use that type of equipment. And when that depth that has been stipulated by a supervisor or manager, depending on what distance the cut scanner found, when it gets close enough to where the underground services are, the operatives switch equipment and they start using insulated spades and shovels. Why? Because they are closer to the services. The services may include electricity or gas. So they start then doing the excavation using the insulated spades and shovels. They do it by what we call hand digging. Hand digging is the use of handheld equipment to locate underground services. It will come in your CSCS. That's hand digging. Okay? Use of handheld equipment to locate underground services. Okay, that's what hand digging does, okay? And they dig what we call trial holes, okay? Again, this will come in your CSCS. Trial holes are dug by handheld equipment to locate underground services. Once that is done, right, and they get to a place that has yellow marker tape or sand, this is evidence of underground services. Your CSCS exam, you will have, you may not, please don't write on the paper.
No,
Ah, okay, yeah. When you get to the exam, they will ask a question of what typically it means when you come across yellow marker tape or sand. Sorry?
And how come the test they said that question?
They said that question. It's very common. Yeah.
What would you also?
It's because once you get to this, it is evidence that you have, there are underground services. Just the evidence. When you're digging and you find yellow marker tape, that's evidence that they are underground services. For example, this is like showing you there's electricity cables or gas pipes underneath there. So stop digging. You've now arrived, effectively. Okay? That's what that means. Okay? The other thing that you're going to also take note of with the services is that they tend to ask about particular gases that are typically found underground. Is hydrogen sulfide, and the characteristic of it is that it smells like rotten eggs. Okay? Smells like rotten eggs. That's one. And the second one is methane gas or methane gas. And this one is odorless. Okay? Now, typically, most, if not all the gases, they put smells in them. Because if they don't, you would imagine the risk. You don't know that it's there and it would explode right in the face. They put smells so that it could warn you that there is gas out there. Okay? Now, that is when we're dealing with services, but let's look at excavations and the safety around excavations. You know, excavations could be tunnels, trenches, any manner of excavation, especially if work is happening in the excavation. There are some safety measures that are put in place. And the first one you need to be aware of, that again can come in exam, is what we call shoring up. Okay? Done that. Okay? For example, you're digging a tunnel that's maybe 20 feet deep. Okay? And you're working in this tunnel. The work here is going to take 2 weeks. Okay? Let's say this is about 15 meters wide. Okay? It's quite wide. Okay? So there are a number of people working in there, doing different things. Okay? The risk is, remember when we talked about plant, working safely around plant, and one of the hazards was soft ground, uneven ground. So what do you think can potentially happen?
It could collapse.
It could collapse inside and you get buried before your time. Okay? So what they do is that they put barriers here that will make sure that this place is left secure. And that's what we call shoring up. Okay? Shoring up. Okay? These barriers are erected not by simple job logs. Just like we have scaffolding that has been put up by someone who's qualified, these barriers are erected by qualified people. Because just imagine if someone does a shoddy job and it collapses in. Huge issue with that. These things have got to be inspected as well. The other risk of working in what we call a confined space here is oxygen. Okay? Believe it or not, there could be other gases that seep through, or if people are struggling to breathe. And what there is now is equipment that is attached onto the high vis.
Like gas monitor.
Sorry?
Like a gas monitor.
Like a gas monitor. So if it detects that there is a flow in the supply of oxygen, it will beep, and then the guys inside here will evacuate as a safety mechanism. Okay, in a confined space. Yes.
How many exits does an excavation need?
To be honest, I'm not sure.
I remember there's some question, something like requirement, like how many exits. Oh no.
I'm not sure how many exits an excavation needs. But one other thing I also know is that you cannot be down there over a period of time. After a certain time, by law, you're required to come out as one of the safety mechanisms. So if it is a whole day's work, you might find that you come out every hour or two as a safety mechanism with the excavations. Okay? One of the challenges here is obviously because it's a confined space, there is an issue of oxygen. Another requirement here is that you cannot work in here alone. Okay? You've got to have somebody like a top man. Okay? In case of anything, there is someone on hand to come to your rescue. You cannot be inside here on your own and other people are doing their stuff. There's got to be someone around, the top man. Can you send me that? Can you help me with that? Is everything all right? Kind of thing. Again, that is to make sure that the person here is safe. Okay? Does that make sense? And the other thing around all open or excavated spaces is that they have got to have barriers around them. Okay? So have barriers around that. Okay? Barriers. Why are these barriers there?
To reduce the risk of someone falling in.
Yeah, to reduce the risk of someone falling in, and perhaps also warning signs. Okay? Warning signs. These prevent other people from falling in or accessing work in progress, and the risks associated with that. So those are some of the areas that you need to be aware of. Now, the guys who've just done the exercise that I've given you, did you find that useful? Yeah? So are you guys ready for your level 1? I'm going to send you downstairs, and then the rest of us, we're going to be doing this very exercise. Is that right? Okay, so I think it's 5 of you. So if you could go downstairs.